The credit card balances in dollars for 100 customers of a credit card company that has millions of customers is just shown here as a data set, as a sample. And then we want to find the 95% confidence interval for the average credit card balance for all the customers, millions of customers in this company, just using this data set. And we consider two scenarios. One scenario is the practical scenario that the sigma of population, or standard deviation of credit card balances in dollars for all customers, is not known. And the second scenario, just to showcase the capabilities of Excel, I'm going to discuss when the sigma is known. So first, just we have this data set. What is the thing we're going to do? So in the ribbon, select the data, then go to the Analyze group, and then select the data analysis. As soon as you do that, then this dialog box shows up, in which we're going to select the descriptive statistics, and then we click OK. The moment you do that, then what happens is this dialog box pops up, in which we have to select the column A, including label, for 100 data points that we have. So input range is from A1 to A101, and then we select labels in the first row. And then output range, I want the output to be in the same sheet. So let's say we select C3 as the place to start placing the statistic table, summary stat. Click on summary statistics so that the table is generated. And confidence level by default in Excel is 95%. So if you want anything else, just change this number. And that's it. Click OK. The moment you do that and you click OK, then what's going to show up is this output. So this will be generated. What is this? All right. As you can see, we have now a table, a summary statistic for credit card balances in dollar. The mean is X bar, so that is the average credit card balance in dollar for customers. So this 9,810 is the X bar, and it's just basically the same usual formula we have seen, sigma I from 1 to 100 in this case, xi, all the credit card balances for these 100 customers, divided by n, which is 100, as you can see, sample size. Now, the other thing that is interesting is the median, of course, the mode happened to be this number because it is just repeated more than any other number. And the standard error is what we used to see as sigma x bar. So standard error is sigma x bar, or standard deviation of the sample mean, which to compute that, generally speaking, we would require the sigma of population, basically the standard deviation of the credit card balances for all million customers that we don't have in this scenario, divided by square root of sample number, let's say square root of 100. So what is then being done here to generate this table by Excel? Excel is computing for you the standard deviation from this 100 credit card balance data set and use that as an estimate for sigma that we don't have, divided by square root of 100. And this S is what we know, the usual formula for sample standard deviation, that is sigma from 1 to n, 100, and then xi, the credit card balance for each of the rows, minus x bar that we just computed to the power 2, and then divide by n minus 1, which is 100 minus 1, which is 99 in this case. Okay, so that is used by Excel to find sigma, and then by this formula to find sigma x bar, which is a standard error or standard deviation sample mean, or the average credit card balance for the sample of 100 customers, which is reported now about $505 roughly here. Okay, so the last point. Based on this data, you can see that the confidence interval, 95% confidence interval, is computed. There you go. It says 95%. So 95% confidence interval is computed here, and it's $1,001.60 roughly. So what is the meaning of this? It means that if we go and we have, let's say, a confidence interval level like this, centered around the X bar, which is here, the 9,810, so $9,810. Then if we go up by this margin of error, or ME, or error basically, so you add a margin of error to this 9,800, and you end up with adding $1,001.60. So add 2x bar, a margin of error, and also subtract from X bar a margin of error. So 9,810 minus $1,001.60 roughly at this point. These are the upper and lower thresholds or lower ends of the 95% confidence interval. It basically means that if X bar is normally distributed as expected, with a center around 9,800, roughly there is 2.5% chance that you end up with mu, or the average of 1 million credit card balance above this number. So there is only 2.5% chance statistically. And there is only 2.5% chance statistically that the average credit card balance of 1 million customers of this company is below 9,000, let's say below about $8,810. And 95% chance that the average credit card balance of 1 million customers of this company is in this range. That is the meaning of this whole thing. Okay, so this was for the case of not knowing the sigma. But let's just, as an illustration, as an example, to show that when the sigma is known, the second scenario, what's going to happen. So what I'm going to use is, I'm going to use a trick, and in that sense, I'm going to make the assumption that we know the sigma, but how? Well, I just said, using this formula here, if I change the color so that you can see, using this formula here, so using this formula, I can say sigma, which is sigma of population. Population meaning that all 1 million customers of this credit card company is rad n, or square root of n, times sigma X bar. Well, rad n is just a square root of 100, which is 10, times sigma X bar, and we just computed here. So $500, let's say, instead of 500, 4.79, let's assume $505. So what I'm trying to say is, it's as if we basically estimate that the sigma of population, or basically a standard deviation of the credit card balances of all million customers in this company, is about $5,050. Now let's assume this is given at the beginning of the problem. Then what should we do instead of using, let's say, the data analysis toolbox and this summary stat? There is a way, there is a command in Excel. There is a command in Excel that I'm going to use right now. So that command is basically equal to confidence. There you go. So there you go. Returns the confidence interval for a population mean. So confidence.norm alpha. Alpha is 1 minus 0.95. So remember that 95% is our confidence interval. Let's say that's the level of confidence we want to track. So 1 minus alpha, or the confidence coefficient, is 0.95. Therefore, alpha is 0.05. So I need to use alpha 0.05 here. So 0.05. And then standard deviation, I just said it, the standard deviation of population, $5,050. And sample size is 100. Okay, so there you go. So what the formula I use, I'm going to copy paste the formula here. This is the formula I use. And so this is the value I found. And you can see that this value is not that far away from, let's say, if I just stay with this value, $990 roughly is close to $1,001 that was computed in terms of confidence interval in the summary stat table I showed you. So all I'm trying to say is the result of confidence.norm is matching what the summary stat did when we didn't know sigma. Compared to this scenario, we just make the assumption that 5,050 is known from the get-go. So when we know the sigma of population, we can just use confidence.norm and compute the 95% confidence interval, since we use alpha of 0.05. Okay, one last point. So we are done with the confidence interval, but just to visualize data, of course, one thing we could have done is we could have just also noticed the histogram. So I can just also go and insert, let's say, a histogram here, let's say like this, and just to visualize what kind of data we are dealing with, I can just say, okay, so let's take a look at the data. So on the on the axis, I'm going to format the axis, and I'm going to select the bin size to be 1000, matching what we had. And this is the distribution of the data set we have in this example for the let's say the minimum. As you can see, we have customers at around $1,300 balance, up to customer around $19,000 balance in terms of the credit card balance. And you can see here is the frequency distribution of the customers, the customers in this sample of 100 customers, and how many of them happen to be in a specific bin of $1,000 range. So that is just informing us about the property of the data set that we talked about. Okay, I hope that this example is helpful in terms of illustrating how we can use Excel to let's say find the confidence interval for a given problem, like the credit card balance for companies, and using a sample that is given to us. And I have shown that how this can be done for two scenarios of sigma not known and sigma known.